Here we go, graphing with amplitude, midline, and period. Maybe first thing you want to do is notice that all the pieces we need here, we know our midline is -2. I'm going to just pick my scale. I'm going to call this -2, -4, -6, but you can use whatever's convenient. First thing I'm going to do is put a little dotted line where my midline is. My amplitude is 4, so that means I'm going to go down 4 from -2 or up 4. So that means I'm going to use a slightly different dotted line here. I'm going to use a different color, but you could just use maybe less dashes. But that means my min value on all my waves is going to be -6, and my max value is going to be +2. Going up 4 or down 4 from our midline. My period is going to be 2 pi divided by my b value 3. So my period is 2 pi over 3. Well, I'm going to do my x scale last. First thing I'm going to do is think about, I have a normal sine function. So it increases, it starts on the line, sine on the line, and it's a positive sine function, so it increases first. So I'm just going to draw my wave from midline to midline. So I'm just going to give myself kind of a target. I'm going to say there's the top half of that curve, here's the bottom half of that curve, here's the bottom half, kind of try to give myself some equidistant curving. And there's a max again. And here's my mins. Well, if my period is 2 pi over 3, that means to go from this midline and go through one wave, this distance right here on my x-axis is 2 pi over 3. Okay, it's not the point down here. This would be the point 2 pi over 3 -2. But that my axis right there is 2 pi over 3. That means when I'm halfway through my period, this spot on my x-axis is half of 2 pi over 3, which is pi over 3. Oh, when I get to my max or my min, that means I've gone a quarter of a period. So either a quarter of 2 pi over 3, or again, half of pi over 3, right here must be pi over 6. So now I know that if that's pi over 6, this is 2 pi over 6. This is 3 pi over 6, but 3 pi over 6 reduces to pi over 2. That means I'm going backwards pi over 6 to get to here, going backwards 2 pi over 6 to get to here, and that reduces to -pi over 3, and 3 pi over 6 to get to here, which is -pi over 2. So all you need to do is graph the mins, the maxes, and the places that it hits the midline. Let's try another. Hang on. Here we go. Let's try another. So we'll go a little quicker here because you can slow it down if you want. Here our midline is 4. Let's see. So midline is 4. Amplitude is 2. Period is 2 pi divided by 1/3. Oh, but we know how fractions work. That means our period is 6 pi. So let's see. That means I'm gonna look at these together, and that means from my midline of 4, that means my max value is going to be 6, and my min value is going to be 2. So let's see. Let's call this 4. Here's my midline. my min value is going to be 2, and my max value is going to be up here at 6. So it's a regular cosine function, but it's a negative cosine function. That means instead of starting at a max, it's going to start at a min. So I'm going to graph it and then worry about my x-axis. So this is the bottom of a cup. Then it's the top of a cup. Then it's concave up. Then it's concave down. Then it's concave up. Here's the other half of my concave up, concave down, concave up. Well, if an entire period is 6 pi, that means right there, that's one rotation through my circle. 6 pi is right here. Halfway through my period, I'll be here, so this is 3 pi. And halfway to halfway of my period, I'm at the midline. So this is halfway there, it's 3 pi over 2. So you can use this as your counting number, 3 pi over 2, then 2 3 pi over 2, then you have 3 3 pi over 2, which is 9 pi over 2. And then 4 3 pi's over 2's gets you to 6 pi. We could also just put 6 pi here. Let's go backwards. All we have to do are reflect these numbers. That means when we're at the midline, we're at negative 3 pi over 2. We'll be at a max when we're at 3 pi, 9 pi, negative 9 pi over 2, and 6 pi. Let's try a couple more. Here we go. Midline. Oops. Midline is negative 5. Amplitude is 2.5. So that means our max value will be up 2.5. So our max value is going to be negative 2.5. And our min value is going to be negative 7.5. And our period is going to be 2 pi divided by pi. Oh, our period's 2. Okay, let's start with our midline. I'm just going to make this negative 5. And our max value is going to be negative 2.5. Our min value is going to be negative 7.5. It's a positive cosine function. That means it starts at a max, and that's going to be the top of our concave down part. Hit our midline, turns into concave up, concave down, concave up, concave up, concave down. Let's worry about our x scale. So our x scale, we go through an entire period when we get back to here. That's where we start repeating our wave. So right here, this must be 2. Oh, halfway through our period, we're at 1. Halfway of half of our period, we're here at a half. That means this must be 1.5, 2.5. We're back at a min over here at 3. Here we're at negative 1/2. Here, I'm just going to write this one here. We're at negative 1, comma, negative 7.5. That means here, we're going to be at negative 2, comma, negative 2.5. One more quick example. Midline. Amplitude. And that means when we combine these two, if our midline is at 3 and our amplitude is 5, that means our max value will be 8 and our min value will be -2. So let's see, with that information, well, let's go to our period. So our period is 2 pi divided by pi over 4. Oh, that's we know how to deal with that. That's the same as 2 pi times the reciprocal of the denominator. Pi's cancel. Our period is 8. So our midline is 3. I don't know, I'll just make this 3. I'm gonna purposely try not to put it on a tick mark. Pay no attention to the tick marks. They mean nothing. You are the master of your graph. So here we are at 3. We know we go as low as -2, so I'll make it just, a little less than that. So maybe I'll make it here. Here's -2. We go as high as 8. So let's see, if this was a distance of 5, then we'll kind of try to be equidistant here. So if this is a distance of 5, we'll make it about the same. Let's make this 8. And that's where that's where the top of our waves are going to hit. It's a sine function. Sine starts on the line. So we know we start on the midline, but it's a negative sine function, so it decreases first. So that's going to be the midline. He's going to do that. He's going to do that. And he's going to do that. Oop, that was way off, but close enough. And our period is 8, so that means by the time we're done with one wave, we're at 8. A half a wave, we're at 4. A quarter of a wave, when we hit this point, sorry about that, better do this first, we're at 2, so that means this point right here, we're going to be at 2, -2. When, even though we are not to scale, so we're at 2, 4, 6, that means this max will happen at -2. And so right here will be at -2, 8. Graphing. Oh.